Welcome to qnawire.
Here we have just a fighter plane or an airplane that's going around a circle like this, because it's coming up and it's going vertical, and then it's going to be inverted up here. So they tell us that at the top of this circle, no, at the bottom of the circle, the radius of the circle is 1,200 meters. The mass of the pilot is 54 kilograms. At the bottom of the circle, the apparent weight, which is the normal force acting here, is 1,680 newtons. At the top of the circle, the apparent weight, which is again the normal force, is let me actually just write that in here. This is actually NA, and this is NC. Is 350 newtons. So we do a free body diagram at the top of the circle, no, at the bottom of the circle, because the radial acceleration is pointing up in that case. So we get NA minus W equals mr squared, which is mv of a squared over rho. So N equals this, and we know that that is 1,680 newtons, so we can solve for v squared. And v squared stands out to be about 25,561 meters squared per second squared. Now we can obviously take the square root to figure out what v was, but it turns out we just need v squared later on, so we'll leave it as that. Now at the top of the circle, we have this situation where the radial acceleration is pointing down. So we have minus NC plus W, the weight, equals MVC squared over rho. So NC is this, and that is given as 350 newtons. And we can solve for VC squared, and that winds up being 19,550 meters squared per second squared. And now we're told that as the plane goes around the circle, there is a constant tangential acceleration. So that says that, again, because we have this path, that the velocity at the end of the path squared equals the velocity at the beginning of the path squared plus 2 times the tangential acceleration times the length of that path. So going from A to C, the length of that path is pi r, where r, or actually, I should actually write that as rho, because that is, and I think this should be rho, this should be rho, this should be rho. Yeah, because I called the radius rho. So it's pi rho. Then we can solve this thing for a sub t, the tangential acceleration, and we get vc squared minus va squared all over 2 pi rho. And that winds up being minus 0.797 meters per second squared. So there's a deceleration. The plane is decelerating as it goes around this arc. Now they ask us about what's happening at point B, where the plane is vertical. And so we can figure out that VB squared equals VA squared plus 2 times this acceleration times the length from A to B, and that's pi over 2 times rho. And we know what this is, and we know what all this is, so we can just solve VB squared is 22,560 meters squared per second squared. Now at that point we have a radial acceleration and a tangential acceleration, and so they want to know what the force on the angle defining the point B, where that's reading the wrong problem. We want to determine the forces that are unheard by the seat of the trainer when the trainer is at point B, right? So we have it's a jet trainer, I guess. So we have, in this case, in these cases, we also have a tangential acceleration, and then something, some force from the seat on there. But we would need to look at that at these two cases. But now we need to worry about this horizontal force balance, or this vertical force balance, because our tangential acceleration is in that direction. So we see that NB, which is this, I guess I should put my B down there, NB equals MVB squared over rho, and that winds up being 1,015 newtons. So that's the force pushing here from the bottom of the seat. And so we can see that that's obviously in between these two. Now on the back of the seat, let's see here, the back of the seat would be this. And so we see that that is, for a force balance in this direction, we get minus W plus F equals M times the tangential acceleration. And that tells us that the force from the back of the seat is 487 newtons. So we want the resultant of these two things. So we can figure out the resultant of this and this. And the magnitude is n square root of n squared over f squared, and that's 1,126 newtons. And we can figure out the direction. I won't go through all the details. Obviously, the tangent of that is this over this. And we get that the tangent, that it is in this direction, and so it's 25.6 degrees up from the horizontal here. So it's like this, because this is quite a bit bigger than this, about double. So we have something that looks like that. It's the net force from the seat on the pilot.